Um, so welcome to the LinkML community call for July 16th, 2026. um, uh, Updates this week. I realized I just realized I did not update the release as part of the slide. I believe this is still the LinkML release that we're on. Um, Corey, is there a more recent LinkML map release?
I almost have the release cut, but we are
Ah,
on RC3.
okay.
So sorry I didn't update that.
Um, No, it's perfect. Then the slides are accurate. And activity in the last month, it feels steady to me as I sort of update these slides each time. But Sarah produced a nice graph, and it's been going up all year. But we're at we're sort of steadily rising with 79 PRs created, 49 merged, and then issues 66 created, 42 closed. So actually maybe calmer water since the issues are a little lower than the PRs. And 35 unique contributors, which was like down by like five or something, but still like incredible. Um, and then working on I think I don't know if we're past floating the idea of the virtual LinkedIn workshop and sort of like further into planning it, but that's going to be happening. Um, uh, our recently closed PR section, still not going to read it all, but I organized this a little differently to kind of based on like where the activity is. And so Corey is doing like a ton in LinkML map. Um, and I'm particularly excited about sort of DuckDB join engine coming into that. Um, Lots of work in Algen, some like important like core stuff with like runtime and schema view that Noel and Silvano and say five I'm working on. I won't spend a ton of time on this, but like thank you all for all this work on generators and sort of core functionality. And we have office hours on the first Thursday of the month, 2 p.m. uh, Pacific time, which is great for me, 10 p.m. BST, which I apologize for, but it would be, I don't think we've had anyone join from Europe, but if you are able to join from Europe in your like pajamas after your family has gone to sleep, I think that would be entertaining. Um, and of course, contact us, especially to present at community meetings and such. Uh, First up, Sierra is going to give us a presentation about microschemas. And I'll stop sharing.
All right, let's see if I can get in here. Good morning, everybody. Wouldn't be a presentation in 2026 without an auto-generated image. And this is probably not the best. I did it this morning, but look, you can actually read the writing. So I guess we're getting better, right? I'm going to talk a little bit about microschemas. If you have more questions or you want to participate in this effort, more directly, please reach out on Slack or via email. I think this is still an evolving concept, as all things are, right? But would definitely appreciate your feedback either here or later. So what is a microschema and why do we want it? I think it's best to look at an example first. I guess for folks that don't know me, I'm Sierra. I'm a developer of LinkML, but I also work on a whole lot of stuff across biology with regards to data modeling and software development. I work for the DOE and the NIH and all sorts of things, modeling data around uh, different kinds of experimental parameters and with LinkML, basically. And so one of the things we're working on right now is a big data lakehouse project in the DOE space that brings together environmental microbiome data, metabolomics, transcriptomics, genomics, environmental monitoring data, and even some human biology. And what we're noticing, of course, is that there are parallels in all of these domains in terms of a data model, right? Some sort of thing is monitored or sampled or processed. It has some sort of a variable that it's using to measure some sort of result at some sort of time in a location with a methodology and there's a result that happens at the end. And this seems, kind of general and broad, and you can kind of see the parallels, but why would anyone ever want to do this? I'm never going to go look at a database full of soil samples that tell me what microbiomes are present in them, and also at the same time be asking questions about human biology, right? Well, probably that hasn't been done very easily by folks before, but you can imagine in the endlessness of time that there are some connections to be made there. Like, what if you were in an environmental toxicant kind of station and you wanted to know what the contents of the soil were doing when you introduced some sort of microbe to help process that heavy metal? How were the humans in that environment reacting to, that heavy metal in the soil? So you can see that there is a use case to be made for cross-querying these kinds of data, but the data themselves are very, very different, and they're collected by completely different people, completely different communities over different, scales of time and space. And so, of course, like, you could say, well, we're just going to make a schema and everybody can fit in here, right? But I think like microschemas as a concept are coming along because that's really, really hard, right? So when you're making a schema that even crosses two different groups together, it means that you're talking to people about their data that has, their very own language and their very own communities around it, and all of their governance is about that data. And a big top-down mega model is very hard to sell, right? And it's very hard to get everybody on board, and it takes forever. But and sometimes the only way you can do that is to make it super generic, right? Like, so everything is a named thing, and every link between those named things is an association. And that works fine. Look, we harmonize the data, but nobody really knows what to do, right? What's a named thing? Like, you can't, down on boots on the ground, you can't really figure out what that actually means. But, to be fair, we're always doing the same thing with some of our schemas, right? We're rederiving the same root class. Everything is an entity. All this repeated work is sometimes wasted effort. So a microschema concept is trying to reuse things without this sort of like heavyweight socio-technical baggage associated with it, which means that probably it's not as a constrictive schema, but it still allows you to compute over it. So let's define it. It's in the working definition for this presentation, it's a building block in a larger schema. It bundles attributes that commonly travel together. It avoids like schema commitment or ontological alignment by necessity to maximize reusability. That doesn't mean you can't customize that and use all the really good work that we've done on ontologies and all that stuff downstream, but maybe at the top level, you're not necessarily committing to one so that you can use it more frequently. And very practically, it's a class or a slot that uses the LinkML meta model element implements. And that's a LinkML meta model keyword, and it has specific meaning right now. Of course, this is very much in development. I'll show you sort of like the generators and the instantiators that actually use this keyword in the LinkML meta model right now, and talk about all the work we have to do to support it. So if this is not making sense or we need to go in a different direction, now's the time to give feedback. But I think like this terminology has gotten a little bit like mushy over the past couple of months when we're trying to develop it. So we talk a lot about microschemas. We also talk about profiles. So microschema in my working definition is the small composing building block that you compose. A profile kind of can be split into two different domains or ways of using it. One is for like conformance. So a profile could be a set of rules that shape a schema. This is a microschema profile. So in some ways, we're talking about a profile when we're talking about a microschema. It basically uses the implements pattern, and it sort of defines what that part of your schema is conforming to. But we can also talk about a profile sort of more in Corey's realm of the world, where you're talking about a derived view of something. So a profile is a restricted or customized view of a larger schema you build by derivation or serialization. So, if I have this big schema like BioLink, which maybe none of you know about, but it's a big, giant mega schema that talks about all of biology from genetics to, clinical work. And a particular organization only uses a part of BioLink. That could be a profile. It's still conformant to BioLink. It's still using all of the same classes, the same names, the same terms, the same restraints, the same constraints, but it's just a smaller version of that. So I think part of the confusion sometimes when we're talking about microschemas comes with some of our meta definitions in the model. If you look at these two important keywords for a microschema, implements and instantiates, they have definitions that are sort of nearly identical, an element in another schema, which this element conforms to. The reference element is not imported, maybe used to check conformance, an element in another schema, which is element to instantiates, right? They have the same domain, they have the same range, and they're both multi-valued, right? But they have different purposes. So, a working definition for this work right now is that instantiates sort of means that if you want your class to follow a specific set of annotated rules, you use the keyword instantiates. If you want implements, you want it to comply with a set of schema elements, but not be in a hierarchy. So you're not doing an ISA or mix-in relationship for that particular class, and you're not importing necessarily another schema into your schema. Those ISA and mix-ins would be a much more strict compliance methodology than a microschema implementation of another schema. So let's look at some examples. I think that helps the best here. If you want to talk about instantiates, about these like rules in the forms of attributes, you can kind of click on this link and see some examples of that in the value sets repo. This is an enumeration, for example, that instantiates a value set enumeration definition. And if you click on the value set enumeration definition, you'll see that value set enumeration definition has a series of attributes. Those attributes then, because this instantiates that class, turn into a set of annotations on every single permissible value. So it's a way of saying, I want to make sure that every permissible value in this enumeration has these metadata annotations, for lack of a better word, but I don't necessarily want to require that every single permissible value has these. So it's purposefully lightweight and purposefully not like an ISA, right? Where you have a strong contract that says this is literally a version of my LinkML element that I want to instantiate with all the same properties and all the same constraints, right? It's sort of a more lighter weight way of passing rules to different elements to make them more conformant but less restrictive. It's very hard to describe, right? Because when we're talking about schemas, we're usually talking about cases where we want that conformance, right? We kind of want a closed world where we can validate this and instantiate them. But now we're talking about sort of looser definitions that are still computable. But implements is the one that I think we should spend more time on. That is sort of like a lightweight ISA. So you're defining a contract in another schema, but you're able to rename the content of that class locally without changing its meaning. You can do this in other ways if you have sort of like an ISA relationship with another class, right? You can tag your slots in that class with aliases. You can use slot usage to refine their meaning. You can write mappings, right? There are already lots of things in LinkML that let you harmonize data more easily. This is just one step in the next direction of being less conformant. So its implements behaves like an ISA, but it's not inheritance. So example, again, is much easier to look at. If you looked at this class measurement result, it has two slots, value and unit, and those slots have ranges and they're required, right? A value might be a decimal, a unit might be a query from the units ontology. They're both required, sort of a typical class, very easy to look at. If I have another class, systolic pressure, that implements that contract, I know that it's going to have two slots because I'm using this implements keyword that somehow map to value and unit, but I don't want them to be called value and unit. For this systolic pressure class, I want them to be called systolic value and pressure unit. And in the slots definition, I'm also going to use that implements keyword to then have a computable hook to go in with my code and say, oh, systolic value is actually a kind of value, but I didn't have to import this schema. right? And I didn't have to conform to the rest of the class, which this example doesn't really show very well, but I didn't have to conform to the rest of the class. I didn't have to, have this be my schema inherit all the things that this schema says that measurement result is related to. I didn't have to inherit the hierarchy of classes above measurement result in order to make systolic pressure, right? So I didn't have to conform with is a hierarchy of someone else's schema. I just was able to use it to sort of like map to that schema in a lighter weight ISA. Right. So I keep saying this over again, but I think the take-home message is just gives us devs the hooks to write more code. So we can validate with the instantiates keyword that we have specific kind of annotations on a class. That's very lightweight, right? Or you can validate the conformance of a class to another class in another schema without inheriting it and without importing that schema. So maybe extension is easier this way with still having hooks back into that original schema. So what do we need to make implements work? Well, on the contract class, because we do want to refer to that contract class via a query, having a stable identifier to identify your class in the source schema is pretty important. Same with the slot. The prefixes of your source schema need to be well defined so that, again, we can refer to that as a query. The implementing class needs to use that keyword implement. It says something like, I conform to this, but I don't inherit to it. If you've worked in other kinds of software domains, this may be starting to make sense, right? It's sort of like an interface. Your slots, of course, have to have the implements keyword as well. Different name, same meaning, you get it. And then, when you're saying that you're implementing a particular slot, remember that you're going to conform to that source schemas or contract classes slots, just maybe with different names or different metadata. Okay, so this is a great idea, but like, what do we actually support today? I think the validator by default pretty much ignores, so that's the basic LinkML validator that comes bundled. Of course, you can write your own validator with lots of plugins. A lot of our projects do that. But the basic validator that comes by default with a LinkML schema project, this implements keyword and instantiates keyword are sort of right now completely ignored. I think even though that sounds like, well, then what's the use? I think that's actually not a bad thing. We should talk about how we want to implement validation here, right? Because it is really trying to make us more able to do harmonization with less, friction. So maybe a validator that came in and said, hey, you used implements, but you did these 5 changes. Of course I did. That's why I'm using implements and not ISA, right? So we should talk about that. There is sort of this optional validator that we've started writing that sort of validates the instantiates keyword. So you can kind of make sure that the annotations that you're adding downstream of an instantiated class are there. It's not on by default. It's definitely beta. So maybe some feedback if you're actually going to try to use this would be wonderful. The JSON schema, Pydantic, Python gen pretty much ignores these 2 things too, but it's carried in sort of the bolus of metadata that we produce as part of a JSON schema, for example. Implements is used in OwlGen. I think that's probably where it originates from. I don't know terribly much about OwlGen. It's not my area of expertise, just from a software point of view, not from a modeling point of view. So yeah, we should probably talk about that too, especially since I don't know very much about it. And then Shackleshen, ignored. Loaders and dumpers, it's passive. That just means it carries it along with it, but it doesn't really, validate it or look at it. So I guess, so that's sort of what microschemas are. They're sort of like intentional, or I guess I should say, that's what implements and instantiates mean in terms of LinkML development on the LinkML side. The way you use them could be for something like a profile or a microschema where you have the need to harmonize data, but the secondary need that your communities are dispersed and they're different, and you need something lighter weight than an ISA or lighter weight than importing a giant massive schema that you're trying to get everyone on board with using. Of course, this doesn't take away from, I feel like I've said it enough. I could probably stop talking now, but there are times when you do want inheritance. Like you do want to have, a concise schema for most of our data, right? We do want to use ISA. We do want to use mixins. ISA is a kind of, it has a single parent, inherits the slots. You can use it for convenience. You can also use it for constriction. It's fantastic. Mixins are kind of like a dual hierarchy, or if you want to bundle together a bunch of attributes that you put on a bunch of classes without messing with your ISA hierarchy, mixins are also very wonderful here. I highly encourage using both of those. It's much easier, right? But if you want something that is like a concrete, small, reusable component that, you know, is less adoptable via the mega schema route or an upper ontology kind of route, then microschemas might be the way to go. Instantiates is an instance of, and implements is a conforms to without inheriting from. The tooling right now is mostly documentative, right? But we're, feedback welcome. And as we use this in some of our projects, at least on my side of the fence, I will probably be developing out the toolkit the way I like it to conform to. So again, feedback more welcome. And that's it. So yes, Corey.
I hate to start off with this question because it's kind of annoying, but so where do I go to get microschemas that people have already authored rather than creating my own and creating the, hodgepodge of a billion microschemas that nobody knows what to use?
Yeah, that's a great question. And, I think there is some work, and I see Justin's on the call too. There's this effort in LinkML to start sort of a repository of microschemas. And you can kind of start looking at what we've put there. I think right now that microschema profile is pretty generic. So if you look here, it kind of defines some basic sort of attribute value classes that have some annotations that we want people to instantiate. So that's that rule-based instantiation of a particular value. So in quantity, we want to make sure that it doesn't have an ID and it must be inlined, right? So these are very generic shapes, right? I can't imagine, somebody from a lab coming in here and saying, oh, that's the microschema I want to use. This is more sort of like for software, right? I know that I have a quantity value. I want to conform the quantity to this particular shape. I want to conform the value to this particular shape. I think there's also another repository, and I'm probably going to get this wrong. Maybe somebody can put it in the chat. There's also a clinical one. Let's see if I can find it. Clinical microschemas. And I think this may be your work, Corey. So maybe
it's not my work. Anne has done an
okay.
amazing job on this. Yep.
Okay. So Anne is starting to look at, in particular, I think they're CDEs. Is that right? So different sort of like composable elements in the clinical space.
They will align with CDEs. The CDE work is sort of parallel right now, but it's definitely the direction that we want to go in. And that's kind of why I poked you in this direction, is the idea that like we should be trying to get people to standardize on things. And so, it's a good idea to reach out and see if we can find a microschema before we author a new one.
Absolutely. Completely agree. Like the whole purpose of LinkML is to make us more harmonized here. And so that's why it's hard for me to give this presentation as sort of like a data modeler, is that I'm like, no, I want concrete. I want concrete, right? I want there to be restrictions on my data so that we all follow the same patterns, and it's very easy to like compute over that. But it's hard to get there just from a boots on the ground point of view, or from a practical point of view. So these kind of let us be a little bit less specific. And you're right that once we do get good at this, and once we have all the tooling to support it, you can totally see how we would reuse some of this stuff over and over again. And we should have a registry of these different microschemas, because they're going to be very useful to people outside of a single domain.
And that becomes especially valuable as we start to like align the work with things like CDEs, common data elements, where we can say, hey, this is a common data element we use in our work, and here's its microschema.
Right. I took longer than I thought I would. Apologize. So I should probably stop talking and let our real presenter present. That work, Kevin?
Yes. Thank you for being a not real presenter. Um, I'm excited because like halfway through that I realized like, oh my God, I need to be using implements for where my application schema is sort of tied into BioLink model, but I don't want a whole class hierarchy to come with it. I just want my nodes and edges, but I want to tie all my slots back. So like I'm I'm excited. I'm going to do new things based on this. Okay, so Stephan Heunis is going to join us. He's a research software engineer at the Research Center in Jülich, maybe. Um, uh, and I'll let you take over.
Cool, thank you. Is the audio fine?
Yeah.
Thanks. Let me just get sharing. Okay, and can you see my screen?
Yeah, we're seeing like desktop Finder window.
Come on. Okay. Sorry.
No worries.
Yeah, that's what my desktop Finder window looks like too. Just screenshots.
There it goes. Yeah, we see slides now.
Okay, cool. And this still works?
Yes, looks great.
Yeah.
Cool, thank you. Hi, everyone. Thanks. It's great to be here. Thanks for the previous talk. That was quite interesting. I think there's a lot of conceptual overlap with stuff that we're doing as well. So I found it quite engaging. Thank you. So my name is Stefan. I'm a research software engineer at Research Center Jülich in Germany, and I made a post on an LinkML discussion a while back, which was about using LinkML schemas to drive data entry applications. And that's very much up our alley. So I made that post, and that led to me being here. So thank you for that. And I want to tell you a bit about our work. We call it ORINOCO, like the river and the Enya song. And it's about building self-hostable research information infrastructure and tools, open source tools to support that. So our group, just a bit of a background, we are a mix of lately a bit more data modeling going on, but historically much more neuroscience, psychology, research focused, but always with sorry, with an act of getting into the depth of data management. So neuroscience data sets can become quite large. They develop over time. We want something in research specifically to be more reproducible. And then for the past, I think almost 15 years, our group and some individuals in it have been working on tools, specifically Git-based tools to help with decentralized data management. So we developed this tool called DataLad. It's a Python tool with a command line API, and it is essentially a Git Annex repository, and it brings the benefits of Git version control to data and large data sets, distributed data sets. It grew out of this realm of large near imaging data sets and trying to manage that. So our group has been active in this kind of development and maintenance of that tool for quite a while now. Also with regards to standards development in that same research domain. So there's this thing called the brain imaging data structure, which is fairly simple in its approach, but it's just a kind of data structure to say, let's all agree to structure our near imaging data in this according to the standard. And then in the development of that, data lab as a tool has been used a lot when it comes to sharing BEDS data sets or BEDS structured data sets. So we've grown from that to basically doing research software engineering full-time and developing open source tools for fair data management full-time. And we do that across quite large-ish research consortia. So you have this situation where you have different groups with different social structures, different goals, but they all have to collaborate in some way, different data types. So how do you do that in a fair way? How do you take care of privacy, personal data privacy, because neuroimaging datasets are often of people? And how do you deal with people having different infrastructures at their locations and different IT regulations or requirements? So we've been working in that domain quite a while now, and this has kind of flowed into where we are currently, where we focus almost exclusively on developing and maintaining tools for that are open source and specifically self-hostable, so that people can gain this kind of digital independence. So I'm going to talk about that. The reason we started getting into the LinkML world is because we have been using Git-based data management for quite a while now, but we had more and more the question of how can we make our work more fair when we work with these large data sets. They require Git, they require a user to understand that this is a Git repository. But how can we open that up to the rest of the world? And specifically, how do we not assume that people want to or can or have the ability to use Git wherever they use it? So we realized we needed a way to kind of say, this is a data lab dataset or Git annex dataset. How do we serialize it such that it is in a format that's really easily transportable? And then how do we deserialize it again into a data lab dataset? And this act of serializing led us to the revelation that we needed to start modeling our data in a much more structured or formal way. And one of our colleagues was at a research software engineering conference or something like that, where they saw a presentation where someone used LinkML, and it was kind of by chance. So we just started looking into that and then realized, okay, well, LinkML is actually quite a nicely powerful tool that fits our needs in terms of data modeling. So over time, I think it's been about, almost 2 years now where we've been using LinkML, and we've developed a set of kind of foundational schemas. And I think this is where conceptually it gets to a similar, not definition, but a similar vibe as microschemas. So we have this basic idea that there's a bunch of concepts that are, or entities or whatever, that are pretty much driven by DCAT and by the provenance ontology, and everything is a thing, everything is a PID, and there's some inheritance in it. But then we use these very specific schemas as foundational components inside other schemas. Not in a way that the previous talk described, because we were unaware of it or whatever the reason, but then we kind of inherit those things into a more use case specific schema, where those are the ones that we care about in a specific application. And we call it data lab concepts, but we've over time also not really stuck to what I think previously was our data lab centric viewpoint. Possibly we'll change the name, but the idea is just we have a set of schemas, we use them to compose other very specific schemas that are used in use case or fit for purpose applications. And the one we work with a lot is called this research information demonstrator. All of these links I can share, but this is, for example, come on, I think I have it open here. Yeah. So we have this docs here. We have, it's called concepts.datalab.org, and foundational is used in here the same as low-tech metadata schemas, and you can see we have things, properties, things related to a study, to resources, to rules, distributions. There's a bunch of them, and I think I need to go back here. Yeah, correct. And then we end up with a more fit-for-purpose research information, even though I would say this one is still quite generic. We don't assume any kind of research domain or something like that, but we have a few kind of generic classes that describe most of what we think is happening in research generally. And the nice thing that also drew us to LinkML is that we can use its generators and develop applications that work off of schemas in different formats. So this is where I get back to the point that I made initially, which is the context is using LinkML schemas in data entry applications. So we work with these consortia, lots of people that have to enter information during the research phase. They collect data, they want to describe it, they want to link a specific data set to a specific creator. The creator is also involved in a project. The project influenced whatever other entities. All of this relation we try to capture as early as possible in the research process, such that it's there, it's captured, and it can be made much more understandable and improve the linkage at a later state. So we needed that capability, and for that we need data entry applications or editing applications, and we need backends, storage, and retrieval API. So we used the shackle exported from our demonstrator schema to drive an application called Shackle View, which we developed. And similarly, we use the Pydantic that's exported from the same schema to drive what we call dump things. It's a server, it's a fast API implementation, and it just allows you to give it records, retrieve records, delete records, etc. Where a record is an instance of a class that has a specific PID. And these tools then speak to each other because they understand each other because they work from exactly the same schema. So I can show you a bit of this. We have the research information schema here. There's availability to download all of the stuff. There's a shackle that drives Shackle View. And this is an example of a Shackle View deployment where it is configured to work from a specific shackle schema. It then derives its views from the node shapes in the shackle. For example, you can see all of these different classes: accolade, activity, person. I can find myself. Stephan. There's me. I have different identifiers. I have some annotations. There's a few standard fields, and then there's a bunch of kind of blank node relations where we have much of these association classes. So you have a person, or let's say a person is delegated by some other entity with qualifying roles, for example. So there's the ability to let the user enter these or edit these as well. And we try to use the user interface to hide that complexity of jumping between nodes, different the class hierarchy. So if you have blank nodes in between. So we kind of do not remove that complexity from the schema itself. We use a lot of configuration on the UI side to remove the complexity from the user. So I can edit stuff here. If I've edited it, let's say I changed my, I just add another name. I can save it. It's asking for a token because we make it very irritating such that people immediately enter a token. And then I can submit these changes. When I submit it, it makes a call to our backend service, and we have the documentation for our backend service here, dump things, and to dump that record in its specific collection. I can also query or just get stuff from the API. Is it showing my shell now? I don't know if I switch screens, if it still shows my screen. Yeah. Okay, so I can just make a quick call to the API and the public collection and for specific records of this class. And all of you can also do this if you want. So then you can see what the type of structure looks like also when it comes to data. And this is also the same calls that the user interface makes when it wants to view projects or person, whatever. It gets all of those records again from the backend. Yeah, and that was that part. And I wanted to show another thing. Once we started realizing, okay, we can have kind of a single schema and it can drive all of these different applications. We started applying it to automation of some steps that work from the data collected in this way. So we have this one. So here you can see a website. It's a Hugo site, and it has an information about, let me show you that again. Information about a person on that website, a colleague of mine. It has some description, some links to identifiers, there are links to the projects, etc. And we use this framework to edit person records, for example. So I can add descriptions of a person, I can give them additional names, I can add pictures of them, upload information, etc. And so here I'm just editing some stuff. I'm going to skip over a few things here. I'm adding another publication record that is then linked to that person. And that's saved, and there you can see the submission part. So I submit information. And this then goes to the backend. I'm skipping a few things here. And then I have a random picture that's basically saying we do curation. So it basically says, look, do some shell calls in the backend to see if there's new information regarding persons or any type of objects or classes you specify, and then use runners on our Forgeo deployment, which I'll mention a bit more in just a second, to fetch that data from the backend, restructure it using some templating tools, and then push it back into the website, the statically generated site. So then, if we go look at that person record again, all the information that we entered via the ShackleView UI, which is generated by the single specific schema, gets back into the website where it wasn't there before. So we find that pretty neat, very, very applicable to our use cases, specifically when it comes to supporting consortia of researchers. And I want to quickly just show you how these tools fit together. So we have our schemas that are then exported in different formats, and they drive specific tools. So I mentioned dump things, and I mentioned ShackleView. So it's kind of the front end and the back end. working from the same schema. And then we specifically also work a lot with Forgeo, and more specifically Forgeo Annexaio, which is a Forgeo that supports Git Annex. So it basically allows us to have all of the support that we wanted for data datasets, where you can push a Git repository and keep all the metadata related to what data adds to the repository, and also host that data on the same Forge. And then Forgeo is great for many reasons. One extra reason is its runner system is pretty cool. So we use Forgeo workflows to then do that work where I said we get all the information from the backend that was edited in the front end. We run very specific querying code and very and sub or output specific templating code, and then generate whatever we need from that. So we currently do it for our lab website, which is where is my lab? No. So I think almost all of the pages that you can see here are generated automatically from the metadata in that backend through the use of Forgeo runners or Forgeo workflows. So we have the same types of stuff that we have for it kind of follows the same schema. So we have people, which is just a person on the Shackle view side. We have projects, we have objectives. We have also updated the workflow to also basically generate a data catalog for ourselves, or for anyone that uses this type of framework. So anything that is in the front end and in the back end as a data set receives the same automated workflows to get that metadata and transform it into something that's a bit more user-centric when it comes to searching for data sets. And we have, let me see here. One of these, we also added recently added like a file browser view. And these individual files also come from the same, or metadata records about those files come from the same metadata system. So we use, I think it's taking a while because there's a few thousand of them. Anyways, it works in the same way. Yeah, there's the same dataset record, and there's many file parts, and the same workflow that we use to generate the website, to generate person pages, we use to generate these types of pages. So that is pretty much our setup currently. It's a snapshot in time. We're developing it constantly. We're growing it. We want to make it more user-friendly, more easy to deploy, better documentation. But I think it's worth discussing with the community, and that's why I like being here. These are links to those individual software components that I already mentioned, that I talked about. I can share this slides afterwards. And then just a quick one on what we see as the next steps. So I mentioned curation, like multiple users can, for example, edit the same record or edit links to similar records. And this is something that kind of needs curation. So when you think about people making changes to data sets in different locations, and they need to collaborate in some way, someone needs to kind of say, well, I agree with this change on that level, but maybe this extra added relation doesn't make sense. Let me accept this one, let me remove that one. So we want to make that process, which currently is only supported by the command line, much more user-friendly. And we also want to improve querying a lot. So we want to be able to say, in the context of this research consortia in collaboration, give me all of the datasets from all of the sites or no, give me all of the files from datasets from various sites that are of a penguin that was captured between where the data item was captured between certain dates, and where the penguin's wingspan was X length. So that type of queries we want to improve, and then as a benefit, package whatever is returned as a deserialized data set as well. So that brings the kind of round to the circle around to where we started when we wanted to improve the serialization and deserialization of our kit-based data management workflow. Yeah. Another thing that I started looking into like a few weeks ago is this LinkML map, because of the fact that we want to map our schema to other places. We don't want to see this. We don't see this as the as kind of the master schema in a very closed domain. We want to make it open so that people can map to whatever they want to, and so that the same data that's collected and curated in our system can be represented elsewhere. And our very specific use case is this Helmholtz knowledge graph, which is Helmholtz is like a big funding and research body in Germany. So that's a very concrete use case that we want to start with using the LinkML map, I think. And then last point is that there's this community called Distribits, which is for distributed data management tool developers, users, and we started this about 2 years ago, and all of what we've done now is also pretty much grew out of that community. So that is a great place for like-minded people to hang out. There's some Matrix chat rooms. I think they should be linked from the website, and we're happy to talk about that and whatever else seems interesting. So thank you very much.
Thank you, Stephan. This is super exciting to me because I think that the use case of like I want a LinkML schema and then I'm going to do data collection via a website like there's not like a great path for that right now. So I'm glad that you're like providing a real option for it. There's probably other questions, but mine was, do you have a generic way to do sort of ownership or sort of private stuff where like a certain set of people can see these records and a certain set of people can see like a different, is that a thing you've had to deal with? Or?
Something I forgot to mention, it's alluded to in some of the images in the slides, but so we use Forgeo also as an identity provider and token management system. So people log into whatever deployment of Forgeo that we have for them as a consortium or a group. They use the token. That token. So the dump things backend is linked to a Forgeo deployment, and that token is then entered into the application, the front end. Like when you edit your data and you submit it. That token is used to identify the user, and all of the data that they submit goes into a separate user-specific collection. And the curation then involves, it goes into user-specific collection, but also there are separate kind of inbox collections versus the curated collection. So whenever something goes into the inbox, it exists in the backend. If someone has curator access, they can see it. But only other person that can see it is the user themselves, and that record always takes precedence when it on the front end side. So their edits they can see. No one else can see it unless it's curated, and unless that other person also has access to a similar collection of data. So the backend supports this kind of separate collections, and we also have. For this deployment that I showed, we have this kind of public collection where we just put most of everything, But then we also have a protected collection, which is just how we name it. It's not, there's no specific design behind the name. But that's more or less how it works. And then your token management is done on the Forgeo side, and that lets people see if they're part of a specific team that then has curator access or access to specific collections.
It's a nice way to handle it. Also nice to have the identity management kind of offloaded.
Yeah, we started when we started with this dump things server, we used it on a we did that on a configuration level, but yeah, that pretty quickly became not manageable. And then soon after that started the integration with Forgeo, and that has just been a blessing from day one.
Other question I had, because I love building these kind of sites, was do you have a way to sort of like configure, like, in a LinkML schema, some things are just like nested down and you don't really want someone to enter, to sort of work with them directly. You sort of want them to get worked with as a deeper part of something. Do you have sort of a way to handle that and kind of hide them from the nav view?
Yes, I think that that's a general question that can be applicable to different parts of the schema. And one thing I mentioned quickly, which is this kind of association clause, like where you say something is attributed to or influenced by everything that comes from provenance, essentially. Where we also actually the big influence of developing Shackle View was this dash data. I don't know if it's vocabulary or there was like a one pager that Berners-Lee wrote a long time ago for using Shackle to drive user interfaces. So that was a big influence. And then there's a one term in the vocabulary is this key info role. It's like a dash property role or something, and the value is key info role. And it basically says that this slot on a class is the one that carries the weight, where the other parts are just like qualifying information. So we use that as annotations. So it comes through in the Shackle as well, where when you see that key info role annotation on the slot, it means that one is the UI then takes that as an instruction to hide the interim or extra slots and just use that. So, for example, yeah, if something is influenced by a project, but the influence by association clause is this weird in between blank node that users don't really follow. You want to have that jump to the project. So when you ask people to fill in the influence by, the drop down already contains all of the list of projects and not this weird blank node list. That's one example. There was another.
Oh, I should stop. It looks like I think we're past time. And,
oh, sorry.
I have to jump to the meeting too. But thank you so much. This is great talk and it's great software. Thanks all.